And what it consists of is an insulator, I'm using styrofoam, and a conductor. This is number 69. And so I've got an insulator, which is the styrofoam, and I've got a conductor, which is this metal plate, and then I've got this little plastic rod, and that allows me to handle the conductor without grounding it. So the handle's not really part of the electrophorous, it just gives you a way to actually manipulate the conductor. So to use the electrophorous, what I do is I get some charge on the styrofoam, and for our purposes today, I want to define this as positive charge. And now if I put the metal plate down, what does the charge look like in the electrophorous, or in the metal plate? Charlotte?
All of the electrons are...
All the electrons are down. They're being attracted to the styrofoam. Will they enter the styrofoam? She's saying no, and she's right. Why won't they? It's an insulator. Good. So you're on camera right now, so you got to speak up a little bit, so I don't have to repeat it all the time. So if we were going to do a drawing, it would look like this. We've got styrofoam, and the styrofoam is positively charged, like I said, and so this is an insulator.
How do you know it's
It's an insulator because basically it's not a metal. And then I've got my metal plate, which is a conductor. And then on top of that, I've got this little plastic rod, which isn't really part of this, but it gives me a way to handle that. And what Charlotte said just a moment ago is that all the negatives in this conductor are going to be drawn down to the bottom of the plate because they're attracted to the positive charges. And so this creates, what's the term for this?
Oh, induced polarity.
Induced polarity. So we've created an induced polarity. We've caused a separation of charges. So in order to use the electrophorous, what I do, watch, is touch the metal. This is now charged.
Why?
I can discharge it, charge it up again, I can discharge it. I can do this all day long. And I don't have to rub the rabbit's fur on the styrofoam because there's no charge change in the styrofoam. There's no charge moving from the styrofoam to the plate or from the plate to the styrofoam. So what happens when I touch the top of the plate? I see one hand. All right, Elliot.
The electrons from the ground come up all the way through your finger to neutralize the positive charges on the top of the conductor, and then when you take it off, there's an imbalance of negative charges to positive charges.
Okay. So when I touched it, I provided a ground connection. And because of the induced polarity, the top of this looks positively charged to the ground. And so as soon as I touch it, electrons from the ground go into the plate. So after I grab the handle now and I take it off, I've got the plate, metal plate with all the positive charges it had before, 2, 3, 4, 5, 6, plus all the negative charges it had before, plus all the charges that I brought into the plate through grounding. So it's negatively charged. And so it's a really convenient way to acquire charge for static electricity experiments. So if I want to charge up an electroscope, I can take my electrophorous, charge it up, and I can always get more charge. Of course, the charge, it makes it look like I'm getting the charge from the styrofoam, but really every time I touch it, I'm really getting the charge from the ground.
Why does the charge go away when you tap it on yourself?
That's a good question. Why does it go away when I do that?
Okay.
Lindsay?
Because you took it off of the insulator?
Yeah, but what's happening when I do that?
The electrons are going back into you?
Yep.
Really?
Yep. So those, and you know the gap I'm getting right there, I got a bigger one before. That's almost a centimeter. How many volts? Jackson?
About 30,000 volts.
Yeah. It wasn't quite a centimeter, so it was less than that. But that was a high voltage shock. Not much charge though, so not a lot of total energy. So when you're out in the lab today, and take a look at how far you can get a spark to jump. And you can kind of gauge how high the voltage is based on that.
Okay, that's it really.